Hi all, I'm K. Surya working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, we are going to discuss on an important topic in digital measurement, which is the power analyzer. So it's an instrument used to measure and monitor power quality in electrical and electronic systems. So in modern industries, electronic applications maintaining good power quality is extremely important because poor power conditions can lead to equipment damage, reduced efficiency, overheating, and even fire accidents. Let us first understand the challenge faced in power systems. So, power distribution networks are usually invisible to us, but they play a very critical role in every electrical system. So, if the power distribution design is poor, it may result in circuit failure, overheating, smoke generation, and costly redesigns. For example, say in a telecommunications, printed circuit board, excessive current density caused overheating and eventually fire damage. This not only damaged the equipment but also caused production delays and financial losses. So, therefore, engineers need reliable tools to identify such problems at an early stage. So, design engineers work under immense pressure because they must balance the performance, reliability, efficiency, and cost while meeting project deadlines. One of the biggest difficulties is that power related problems are often discovered only during the final stages of testing. At that stage, correcting the issue becomes expensive and time consuming. Traditional testing tools usually identify the problems too late. So, engineers require advanced instruments that can detect the issues early during the design process. This is where the power analyzer becomes very useful. So, a power analyzer helps engineers identify the weak points in electrical circuits before the failure occurs. So it can detect traces carrying dangerously high current density and locate areas where voltage drops or overheatings may occur. Now, by providing clear information about the current flow, voltage variation, and thermal behavior, the analyzer allows engineers to redesign the system before manufacturing. So, in this way, it helps prevent catastrophic failures such as smoke generation, overheating, and fire hazards. So, now let us understand what a power analyzer actually is. So, a power analyzer, also known as a power quality analyzer, is an instrument used to monitor the quality of electrical power supplied to a load. Good power quality means that the supply voltage remains stable within the specified limits. So the AC frequency remains constant and the waveform is smooth without distortion. So if these conditions are not maintained, electrical equipment may malfunction or become damaged. So the major parameters measured by a power analyzer include voltage, current, frequency, waveform quality, harmonics, and power factor. Power quality may become poor due to the several reasons such as voltage dips, voltage swells, transient currents, harmonics, and interruptions in power supply. So harmonics are unwanted frequency components that distort the waveform and reduce system efficiency. Similarly, sudden voltage variations can damage the sensitive electronic equipment. So the power analyzer helps technicians identify these issues quickly so that corrective measures can be taken immediately. So thus it improves the system reliability and protects electrical devices from failure. So power analyzers are installed in at different stages of the electrical distribution system. So the first stage is the main switchboard where the highly accurate analyzers are used for overall monitoring of the power system. The second stage is the distribution switchboard where analyzers continuously measure the electrical parameters and provide alarms whenever abnormal conditions are detected. The third stage is the secondary switchboard, where analyzers monitor the status and power consumption of the individual loads. Uh, connected at the end of the transmission lines. So this arrangement gives complete information about the entire electrical network. So there are two methods used for measuring the electrical parameters in a power analyzer. The first method is the direct current measurement, in which the circuit is open and the analyzer is connected directly. The second method is the indirect current measurement, where a current transformer clamp is attached around the conductor to measure the current without disconnecting the circuit. Clamp-based analyzers are preferred in maintenance and inspection work because they are safer and easier to use. In three-phase systems, analyzers use three separate clamps to measure all phase currents simultaneously. So if the current exceeds the analyzer's input rating, an external current transformer is used to convert the current into a measurable signal. So now let us discuss about the working principle of the power analyzer. So each channel of the analyzer contains voltage attenuators and current shunts, followed by high impedance buffer circuit and gain stages. So the analog electrical signals are converted into digital signals using the ADC. After conversion, a DSP processor processes the data and calculates the important parameters such as RMS value, power factor, phase angle, harmonics, impedance, and true power. Modern power analyzers also support communications through serial interfaces, LAN connections, and GPIB interfaces, allowing remote monitoring and control. Digital calibration improves accuracy and eliminates the need for manual adjustments. So, power analyzers also help engineers during testing and validation of the PCB designs. They assist in optimizing component placement, reduce the crosstalk, improving grounding, and selecting the correct copper thickness for power handling. Proper stitching near connectors also helps support high current paths safely. So these improvements increase the reliability and ensure different operation of the electronic circuits. So modern power analyzers are designed to integrate directly with the PCB design software such as Altium Designer. So this allows the engineers to perform analysis within the design environment itself without switching between multiple tools. As a result, engineers can identify the problems safely and earlier, redesign quickly, and accelerate the entire product development process. So, looking throughout the future, power integrity and energy efficiency are becoming more important than ever. So today's industries focuses heavily on performance per watt, sustainable design, and low energy electronic products. So governments and industries are also emphasizing decarbonization and energy conscious technologies. Therefore, power analyzers will continue to play a vital role in designing efficient, reliable, and environmental friendly electronic components and systems. Uh, so this is why the power analyzers are used for. Say used to monitor the energy efficiency testing, harmonic analysis, compliance testing, and transient and inrush current measurements. So to conclude, we can say that power analyzer is an essential measuring instrument used to monitor the power quality and analyze electrical parameters such as voltage, current, harmonics, frequency, and power factor. It helps the engineers detect the faults earlier, improve safety, and optimize the circuit design and ensure efficient power utilization. Because of these advantages, power analyzers have become indispensable tools in modern electrical and electronics engineering. Thank you for watching this video.